good one. Dog toy ball. And we need another one. Maybe a chew toy, like if the dog has a rope or I don't know, a squeaker toy.
Believe it or not, my dog only plays with the toy ball that we have because most of the time his other toys are just his dog bed and a boiled egg.
Well, we need another object here. Something, I don't know, a pillow. Pillow would be okay. Maybe a small pillow. You have something like
Yeah,
that.
pillow can work, yeah.
Okay. All right. So the you're going to come up with four objects. These are just recommendations, and any uh, 1.5 meters is about 5 feet. So maybe height, level, or you can mark the wall if you want, or mark a distance where you're going to drop them from. But you're probably going to need some help when you're doing this lab because it's hard to drop it and start the stopwatch. Um, But what you're going to do here is you're going to drop the object and you're going to record the amount of time that it takes to hit the ground. And you're going to do it for each of these objects. Okay, so I'm
Got
going to
it.
make a table here so that you can record your data. Object. Okay, so trial is like one, two, three trials. So the first object, I'm just going to go with what we said here. Uh, and then we'll go with the quarter and the dog, the toy ball, and the small pillow. And so you're going to record the times in this table, the time it takes to hit the ground. So you can use your phone, you can use an app on your phone. I mean, they make a recommendation for that. Um, so I'd like you to do is to try to write this description of the procedure in your own words
Okay,
of what we're doing.
got it. Okay, I just wait, dang it. Okay, I wrote the steps for the labs in my own words. Also, are you on mute? Because I can't hear you say anything if you are talking.
Oh yeah, there we go. Yeah, thank you. Yeah, slightly was muted there. So that we want to not list the steps, we want to make it more of a narrative. First, take the object that is the largest in size and drop it from a height of 1.5 meters. Uh, so you want to say what you did. So like pretend like you already did it. Like what did you do? Then measure, and then you have it here, the time it takes to hit the ground. The time it takes to hit the ground, period. Um, repeat. So you have to decide, are you going to drop the same object 3 times or are you going to drop them all and then drop them all and then drop them all? I would recommend dropping it the same object 3 times. Okay, so first take the object that is the largest in size and drop it from a height of 1.5 meters. Then measure the time it takes to hit the ground. Drop the same object, we'll say the same object 2 more times from the same height and record the times. Okay, now this is where you repeat, and this is where I want you to add in a sentence here. I want you to basically say that you're going to repeat this for the other 3 objects. You're going to repeat these steps for the other 3 objects. It's kind of what you say down here, but we don't want to list them as step numbers. We want to actually just use more of a narrative language.
Got it. So do you want me to like rewrite it or
I'm asking you to write the final sentence that says that you're going to repeat what we just said, but for
right,
the last 3 objects here.
all right. So like what I just ran a chat, would this work or do you want me to add more?
So again, we don't have step. Like you cannot refer to these steps here that are in the like when you say repeat the steps 1 through 3, you're referring to something that isn't listed. I know you initially put 1, 2, 3, but you're supposed to write it as a narrative. So
Oh,
repeat
okay.
these steps. Okay, but it's not two more times. We've already said that. It's repeat these steps for the other three objects. That's all I was looking for. Because we've already
Okay.
said that we're going to drop the same object two more times for the same height and record the height. And then I mean, you can throw in a word like finally, comma, repeat these steps for the other three objects. Okay, and then you're gonna record the data. Any questions that before we look at procedure number 2?
No, I'm good.
Okay, so let me grab a snip of this. And you'll want to get a picture of yourself dropping the object. So, okay, it says procedure number 2, varying the heights. Take the object that took the longest to hit the ground when released from a height of 1.5 meters. Okay, so we don't know which one that is, but it'll probably be the coffee filter, And then release this object from a height of 1 meter. Record the time that hits the ground. Um, and then you're going to you also release it at these other heights 1.2, 1.4, 1.6, 1.8, and 2 meters, but you're going to have um, 3 measurements at each height. Okay, so your data table is going to look a little bit different. So we're going to yeah, let me do a slightly different table here for you. Insert table. So we're gonna have the height and then the trial number 1, 2, 3, 4, 5, 6. Okay, so this is the height that you're dropping it from. So you're starting at 1.0 meters, and then you're gonna do 1.2 meters. Actually, let me just put that in here rather than writing any time. 1.4, 1.6, 1.8, 2.0. And then you're gonna do it 3 times, trial 1, trial 2, and then trial 3. So you're going to take whichever object took the longest to the ground, which is probably the coffee filter, presume that, and then you're going to drop it from 1 meter 3 times and record the times. Then you're going to drop from 1.2 meters and record the times, and then so on. Do
Got it.
you have kind of a visual of what's going to happen here?
Yeah.
Okay. So when you write the procedure now, you want to use words like first, second, then, or you can say then, and then third, um, you know, finally or lastly. That's how you indicate the steps of what you're doing. So you're up here. Give this a try, figuring out the description and how you're going to put these into step form. So you can't use like 1 and 2 and 3. You have to say um, first, second, then, and so on.
Gotcha. Oh no, I wasn't done. Why did I? No.
That's okay.
I did not
Okay.
mean to click enter, by the way. I did not.
I think you can even delete them. If you don't. I mean, I'm not gonna look at it. You can just
I'm almost done typing this, by the way.
Good.
All right, there we go. I think I did it right.
Good. Look here. All right, so again, no first person. First comma, take the object that took the longest to the ground from height meter. Uh, maybe just say yes, select the object. That's fine. Um, next, comma, release the object from a height of 1 meter and record the time it takes for the object to hit the ground. Then repeat the same steps. So it's two more times. So that when you say that you dropped it, that's trial one, but then trial one, two, and trial three is two more times. So that you have a total of 3 measurements for each object. Finally, repeat the steps of dropping the object at different heights, 1 or 2. Here, okay, and recording the times. Okay, very good. That's your procedure. You're going to fill in the table, and then the results section. And you don't forget to add your pictures. That's important here. For your results section, the only thing it says here, which uh, we'll have to do once you've done it, is present the data and sort of a table or graph, which you kind of have, but you actually would want to graph some of these to see some stuff, depending on what you do. So
Got it.
uh, that is everything for this lab. Um, it does say in the discussion to include. Ooh, I'm not going the right way. Uh, detailed discussion how to compare the Excel spreadsheet and the real labs in this lesson. I mean, I think you can talk about how I think you'll find that um, well, it's going to be very challenging to record the data with the object dropping, but you'll do the best you can. I mean, it's going to happen so fast, you're not going to be able to maybe necessarily see a huge difference in it. Okay, so that's kind of everything for this lab. I'm looking back at your class here now. So you can see we've covered, advanced. We've got the procedures. You'll get the data results, and then you'll submit the lab, or we can do the analysis and discussion together. So that is everything for this lab. So should we go back and look at the next lesson?
Yeah, sure.
Okay. All right. So let's show all remaining lessons. Lesson 13, motion. Motion. Okay. So let's start with this. I'll get a new document going for lesson 13. And we'll try to answer some of these questions here. Okay. So the first thing here to get this picture in, I'm gonna share that now. All right, so this is kind of like one of the things we're talking about with vectors earlier. So it says A to B to M to N. That's weird. Why are they giving you multiple? Let me read this one more time. A to B to M to N. A to B to M to N. B to A. G to D. Okay. It's a little bit odd. So they're trying to get you to figure out distance. Okay. So if you were to go from A to B and just count, how many, how far have you gone just counting from A to B?
Like like from A to B, that'd be like 4.
So you never
Wait.
count the first one,
Oh yeah, sorry, 3.
3. So from A to B is 3. From B to M. So sometimes it gets tiresome to count. So you can actually take the right and subtract the left. So 10 minus a minus 18. Sorry, 10 minus a minus 8. What does that become? 10. This doesn't show it very well, but
Like 18?
yes. Okay. And then to go from M to N is how much? How many units is that?
1. So like 22 is the total.
Yes. Now, displacement is sometimes the same as distance, sometimes. So displacement accounts for direction. So if you're going, and I guess I should put this up here. So if you're going to the right, right is positive, left is negative. So in this problem, your first one you're going to the right each time, so it's going to be the same. But you'll see in another problem it may not be. Okay, so for the next row here, C to A, you're just counting. For distance, you're just counting. Or you can do right minus left. You can do so from like C to A, you can say it's -6 minus a -11, or you can count.
That would be 5. Wait.
That's right, it's 5.
Yeah, 5.
How about from G to D?
From G to D. Okay.
I'm sorry, I guess you got to go A to G as well. I'm sorry, A to G. The G.
That'd be like a +2 minus 11.
Minus a -11. Yeah.
So that'd be 13.
Okay. And then G to D.
That's gonna be a 2 minus a 4, and that's gonna be 6. So that's gonna be 24.
Okay, very good. Now this displacement will make more sense here in a moment. So you started at C. Like imagine you're physically standing at C. When you go to
Okay.
A, you're going left. So you're going -5 left. Then you're going back to the right G. That's positive. And then you're going back 6 to D. So if you started at C and you ended at D, your displacement is just that distance away, which ends up being 2 to the right. Like you started at C, you went to A, then you get over to G, back to D. But how far are you from where you originally started? And that's displacement. You can think of it as how far from where you started. And do you agree that it's that B is just 2 to the right of C?
Yeah.
Okay. So in distance, they're all positives. Like you're on a cruise right now. Do you end at the same place that you started?
Yeah.
But your
We started out Florida, we're gonna end in Florida.
your displacement is zero. Like you you ended where you started, but your distance, you went all over the place. I don't know where you went, but it doesn't matter, but you've been all over.
Yeah.
And
Okay.
so that's the difference. It's when you go ice skating, go to practice, you enter the rink, you start skating around, but then um you return back to where you started.
Oh, so that would be where my coach is basically like it's near the hockey stands and that's where I always meet up with her, so that's where yeah.
Okay. So the idea here is distance is always positive. Displacement can be positive or negative depending on where you finish relative to where you start.
Mm-hmm.
Okay. So J to I. J to I. Let's focus on distance. How far is it from J to I?
From J to I, that's one.
Okay. Now, what you could do, because it's going left, you could say -1 for displacement.
Okay.
Now, from I to E, how far is that?
That's eight.
8. And is it going left or right?
Going left, so it'd be -8.
Okay. And then E to H. So now you're going back to the right. How far is that?
Mhm. E to H is three. I'm sorry, no, seven.
7. And is it going left or right?
Right.
So right is positive. All right. So your distance is okay, you went 16, but your displacement is that if you think about where you started at J and you ended at H, you ended up going just 2 to the left.
Mm-hmm.
So this is more math, uh, like math. I mean, it's not algebra 2 math. It's just some math. Um,
Yeah,
will you try the last one for us, please?
sure. So F to B, that's eight.
Go ahead and now just work it all the way out.
Okay.
And you can use the chat if you want to type some numbers in or
So for the distance, it would be 30,
Okay,
and then
so
the displacement would be. Now I gotta work on the displacement. Okay.
it's going to be the same numbers, but some might be positive and some might be negative.
Yeah. Okay, so -8. So for the displacement from K to F, it gave me a +8. Should I write a -8 or a +8 for the displacement?
So we said right is positive, left is negative. You have to decide which
So
way
it
you're going.
well it goes to the left, so it's gonna be a -8. So the answer for displacement would be 0.
Yes, exactly. Because you ended where you started, where you ended.
Yeah.
Okay, very good. Very, very good. All right. That's an important concept. A lot of people never really fully grasp that. So good job on that. You might
Thank you.
need a calculator for the next part here. Very light calculations. So velocity and speed are related to what we just did up here. We're gonna need this information. So the distance is rate times time. Your rate, which is your velocity, or your speed, is your distance over your time. So the way to do this table here, the way to fill in this table, and we'll look at up here. So it's to take 22, your distance, divided by 5. Now, if you want to know where 5 comes from, they're telling you it's 5 seconds. And then the next one was 24 divided by 5 seconds, and 16 divided by 5 seconds, and 30 divided by 5 seconds, and so on. And then 22 divided by 5, 2 divided by 5, -2 divided by 5, and then 0 divided by 5. So you're gonna have to grab a calculator and calculate each of these. One of the things it doesn't say is the units. Let me take a look at units here. Do you have a calculator handy, or can you use one?
I have my phone.
That will work. You can also use the Desmos scientific calculator. They call these meters, so that's going to be an important thing here. It's going to be meters per second and meters per second. So see if we can get these done here in the next minute.
Okay. So for the first one, it gave me 4.4,
Okay, keep going.
4.8,
Okay,
3.2,
okay,
6.
okay. All right. You can just go to the next one. That was just a repeat of the previous one.
2 divided by 5 is 0.4.
Okay. And how about
And
0
then
divided
0
by
divided
5?
by 5 is 0.
Very
There
good.
you go.
All right. This is a great stopping point for us for today. Good job. So we're going to pick up here tomorrow.